So a second video here, exact values of sec, cosec and cot, part 2. Let's jump straight into an example. So the question is sec pi on 6 times cosec 5 pi on 4 plus cotan negative 2 pi on 3. Now, you just do them one at a time. Do this one, do this one, do this one, exact value, exact value, exact value, this times this plus this. So let's give it a crack. Sec pi on 6 is simple because it's in quadrant 1. So that's going to be the same as the reciprocal of cos pi on 6. So it's the same as 1 on cos pi on 6. Alright. Now, cosec, it's going to be 1 on sine 5 pi on 4. We might need to do a little bit of something there. And plus 1 on tan negative 2 pi on 3. Now, cos pi on 6, adjacent over hypotenuse, root 3 on 2, but I'm going to do the reciprocal, so it's 2 on root 3. Okay, so now I've got a nice little number there. 1 on sine 5 pi on 4, so pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, C-A-S-T. Okay, that's going to be the same as 1 on negative sine pi plus pi on 4. And I'll just write the next line as I go here. Times sine pi on 4, 1 on root 2, so it's going to be root 2 on 1, but it's going to be negative. It's going to be negative. Sorry, just strayed off my screen a bit. 2 on root 3, you know what I'm doing. And this next one is 1 on tan negative 2 pi on 3, pi on 3, 2 pi on 3, so it's in here somewhere. There we go. That's pi on 3. So that's the same as plus 1 on tan pi plus pi on 3, which is the same as 1 on tan pi on 3. It's in the t quadrant, so it's positive. And tan pi on 3 is opposite over adjacent. It's root 3 on 1, but reciprocal, so 1 on root 3. Now I'm just going to stick this all together. We have 2 times negative root 2, 2 over root 3 times negative root 2 over 1, which is just root 2. So that gives us 2 times root 2, but it's negative, over root 3, and we're going to add 1 over root 3. Adding fractions, so the denominators stay the same. Root 3, negative 2 root 2 plus 1. That's a really decent final answer. Now, of course, you could rationalize the denominator. So to rationalize the denominator, you'll multiply top and bottom by root 3. Root 3 negative 2 root 2 plus 1 over, and root 3 times root 3 is 3. Now you could use a distributive law there and expand that, but I think that's close enough. Okay, that's another example of exact values of sec, cosec and cot.